Tyler. Okay, so I want to start with the question. How do invariants of varieties behave under finite group actions? So I just finished my PhD at the University of Edinburgh, and in my main project, I was thinking about this in the context of Bridgeland stability conditions. If you're interested in that, please come talk to me about it later. But today I want to talk about something else. So this is joint work with Augustinus Jatsovskis and Franco Rota, something we put on the archive back in October. So let me tell you this fact to begin with, which is that if X is a smooth Fano variety over C, and we have an equivalence of the derived category of X with the derived category of some other variety, doesn't have to be Fano, then it turns out, due to Wondel and Orlov, that these two varieties are isomorphic. So this big invariant of all of your coherent sheaves and chain complexes, it is an invariant, it knows about your variety. But this is huge. So we want to ask, do we need actually less information to determine a variety? And for example, if we take X and X prime to be cubic threefolds, then the derived categories have what's called a semi-orthogonal decomposition. So basically, all of your objects are generated by extensions of these line bundles and then kind of everything that's left over. So this is this Ku, which is short for Kuznetsov. This is called the Kuznetsov component. And it's a result due to Benedara and others from about 10 years ago that if you have an equivalence of these smaller subcategories, whatever they are, it still determines your variety up to isomorphism. Now, much work has been done over the last decade to generalize this to other Fano threefolds. In some cases, you only get birationality here, for example. So this is where this project about cyclic covers comes in, that I'm going to tell you about. So I'm interested in branch cyclic covers. So I mean, suppose we have an n to 1 cover branched in a divisor like this, with an action of the cyclic group of order n on the top, then what we'd like to do is have something like, if you have an equivalence of Kuznetsov components, then can you somehow get an isomorphism of these branch divisors and use that to reconstruct your variety? And the key fact here, so what I forgot to tell you, is that this is called a categorical Torelli theorem. That's a CTT. So that's what we're trying to do for these examples. And the key thing is that dbx itself, somehow it doesn't see z, but if you look at the derived category of the quotient stack with this group action, it does. So this is really equivariant, the derived category of coherent sheaves that are equivariant with respect to this group action. And that's what we use to recover our variety for some new classes of Fano varieties. So the theorem that I want to state vaguely is that we get a categorical Torelli theorem for two new families of Picard rank 1 Fano threefolds. And for some context, there are 17 of these, and it was open for kind of 5, and so we've settled 2 more. And yeah, the thing I want to leave you with is that the answer then in this context to this question was that by looking at the group action, we could, like, our invariants became richer. We found out more information.